Okay, so let's start today's doubt session. So first I will discuss the test paper, right? So today's test paper, any doubt, any questions if you have, you can ask. 10 questions were there, and question number 10 I will take first. A circular road of radius 250 meter is banked for a certain speed. So there is a road and this road is banked. This angle theta is the angle of banking. You remember this diagram? There is a car which is going like this way. Okay. Right, and the road is 10-meter wide. So suppose this road is 10-meter wide and outer edge and inner edge again they are saying. So they are talking of a road like this. If you remember some questions previously also you have solved in the modules. It is like this they have given the road. Okay. So this is the outer edge and inner edge 10-meter wide. So this is 10-meter wide and the outer edge is 1 meter higher than inner edge. So suppose this distance is h1 and this is h2. So h2 is larger by 1 meter. That means this delta h is 1 meter here, and this is 10 meters. Okay. That means this tan theta you can easily calculate from this, which is 1 by 10. Okay. Then they are saying that what is the optimum speed for car to negotiate the curve without relying on, that means you do not consider friction. Let us consider no friction, and you are going in a circle of radius r. Now there is a direct relation already we have derived, but if you want you can derive. Normal will be like this way, mg will be like this way, friction is not there, so these are the only two forces, right? So normal is acting like this way, and you know this mg is acting like this way. You already know that this angle is theta. So normal you resolve, normal cos theta, normal sin theta. This is resolution of the forces, right? So now here when you resolve forces, you can see that this body is only going in circular motion, horizontal, so net force must be horizontal. This net force is the total force, which is nothing but the centripetal force. So and sine theta is nothing but centripetal force, which is mv square by radius, and this has to balance when cos theta is equal to mg. Now when you take the ratios, and will get cancelled, sin by cos will give us 10, mass will go away, v square by gr. This result you already know that, so v is root under gr tan theta. Then you have to just substitute the values. So speed becomes root under g is 10. Radius they have given in the question. What is the radius they have given in the question? 10 meters. And tan theta already we have calculated 1 by 10, correct? So now you calculate radius is 250, radius is 250 they have given. So cancel out, you got root under 250, that means it is 5 root 10, that is the speed meter per second. Yes, now ask question. Yeah, that's what it is, right? AC by G. AC is V square by R and divided by G. That's what it is. Then any other questions, doubts, any conceptual thing ask. Okay, 1 minute. Question number 15. A particle is revolving in a circular path of radius 25 meter with a constant angular speed of 12 revolution per minute. So body is going in a circle Radius is r is given 25 meter and the constant angular speed. So whenever they say angular speed, but they are giving the units of revolution per minute, so they have given frequency 12 revolution per minute. So you convert into second first. 12 revolution 60 second. So that become 1 by 5, right? 1 by 5 revolution per second is the hertz, right? That is the SI unit. Now you can calculate omega. What are they asking here? Angular acceleration they are asking. Okay, first you calculate omega. Omega is 2 pi into frequency. So 2 pi into 1 by 5. That means 2 pi by 5. So they have given that it is going with a constant angular frequency means constant angular speed. That means what type of circular motion it is? Tell me. Uniform circular motion. Only what kind of acceleration it is? Centripetal. But they are asking here angular acceleration. Calculate angular acceleration. That means alpha. They are asking alpha. So tell me formula for alpha. Now you tell me differentiation of omega. That's okay. Differentiation of this. First of all, you are telling that omega is constant. Now you tell me now what is differentiation of constant. Then, then why you have to do anything? Because it's a uniform circular motion means there is no angular acceleration, no tangential acceleration. Okay. Then question number 17. Last option, option D, 0. What is the problem? Ah, you write it. A means tangential acceleration. No, no, no. Tangential acceleration is R alpha. No, forgot formula. Tangential is R alpha. This is formula. So tangential acceleration is anyway 0 na, because speed is not changing. So from here also you can calculate. It is also 0 from here also. Today worksheet I don't have. Can you send me that? Mock test you are saying, na? No, no, no. I think in the school they have given something, right? So can you send me that? Or give the question. What is the question? Tell me that question. Send it in the group. Hmm. Hmm. Rotation thing right now leave it now because that is not required right now. No, no, no. We cannot solve right now. We'll solve it afterwards. Okay. Okay. Yes, I think I got it. Question number. Which question number you are saying? 15. 15 and 7. Okay, the shaft of an electric motor starts from rest, and on the application of a torque, it gains an angular acceleration. So alpha angular acceleration is given 3t minus t square. Okay, alpha is changing with time during the first 2 seconds, and after, so that means this acceleration of alpha is from 0 to 2 second only. After 2 second, alpha is 0. Alpha becomes 0 after 2 second. After 2 second. Okay. That means before 2 second, 0 to 2 second, alpha is changing with time. After that, alpha becomes 0. Alpha becomes 0 means it is going to be uniform circular motion after that. Right? Okay. During the first 2 seconds. Okay. The angular velocity after 6 second will be. See, they are asking angular velocity after 6 second. Why? After 2 seconds itself, omega become constant. Right? Try to understand that. Because after 2 seconds itself, there is no acceleration. So after 2 seconds itself, omega become constant. So whatever omega is there after 2 seconds, that is same omega at 3 second, 5 second, 8 second, 9 second, 6 second. Okay. So if you can calculate omega here, that will be same omega afterwards. Okay. But omega is changing here to here in 0 to 2 seconds, that we need to calculate. So basic simple idea is there, and is it starting from rest or not? Yes, starting is omega 1 is 0, right? Omega 1 is 0, is starting from rest. Thaman is also right. Okay, fine. So welcome Thaman. Any doubts are there, you ask. Okay. So this question we are discussing. So omega 1 is 0 first of all, right? So it is because it is starting from rest. Okay. Then in the first 2 seconds it is changing. So at 2 seconds, what is omega? Because after that it remains constant. So omega is changing between 0 to 2. So alpha is d omega by dt. We have to write differential equation because alpha is not constant. Remember, where alpha is changing with time, that is called non-uniform angular accelerated circular motion. Remember, right? Remember, alpha is 0 means uniform circular motion. Alpha is constant means uniform angular accelerated circular motion. Alpha is not constant means non-uniform angular accelerated circular motion. Right? So that's what is the case, and in that only differential equation we have to use. Now you need to know how to do differential integration. Okay, let us do that. We want to calculate omega, so let us write this as alpha dt, that becomes equal to d omega, and let us now integrate it. So omega initial is omega is 0, final omega is omega, and initial time is 0, final time is t. So 0 to t we will integrate it. So integrate this. Alpha is given. Alpha is here given as 3t minus t square. This integration you know how to do that. 3t minus t square integration you should know how to. And this is changed. That means final is omega minus 0. So that's what is omega. You got omega, but this side you have to do integration now. Do that integration 0 to 2 seconds. First term 3t dt. 3 comes out. T integration is t square by 2. Minus second term is t square integration t cube by 3, and the limit goes from 0 to 2. So do that integration. So 3 into upper limit you put 2 square by 2 minus 2 cube by 3. Lower limit is 0 0 only, so leave it. So calculate this omega. So here 2 2 got cancelled. So 3 into 2 6 minus 8 by 3. So solve this. This LCM you take as 3, right? So take 8 into 3, sorry, 6 into 3, 18, 18 minus 10 by 3. That is the answer, radian per second. And that remains constant after 2 seconds. So that's the value of that. Okay. Next question is 17th question. Yes, tell me any doubt. Hmm. It is given, na, alpha is not constant, na. Alpha is changing with time. You see in the question. You see, alpha is neither 0. If alpha is 0 means uniform circular motion. If alpha is constant means acceleration is constant. But alpha is changing with time. It's a non-uniform angular accelerated circular motion. So we have to use relation of alpha omega with differential equation only, right? So that differential equation we use. Yeah, the function will be given. According to function, you have to do integration. Then any other next question also I'll discuss that question. Question number 17, right? The vertical section of a road over a canal bridge in the direction of its length is in the form of a circle of radius. So then find the greatest speed at which the car can cross this bridge without losing contact with the road at its highest point. The center of gravity of the car being at a height h above this point. So suppose this is a bridge like that. They are saying it is a bridge, vertical cross section of road over a canal bridge in the direction of length. This is like a circle. Okay, and radius of this bridge they have given. This bridge radius R is 8.9. Okay, meters. Find the greatest speed at which the car can cross this bridge. So suppose there is a car. Okay, this is a car. This car is trying to go over this, and when the car comes at the topmost point, that time some speed will be there. We have to find the maximum value of this speed. Okay. Yes. Send it. Send it. So this is the maximum speed here at the greatest speed at which the car can cross this bridge without losing contact with the road at its highest point. So this maximum speed they are asking at the highest point. The center of gravity of car being at a height h above the ground. So center of gravity means here somewhere. Center of gravity means here the mass is located. Mass is somewhere here m. Okay, which is at a distance of from the ground means from the bridge. Okay, this height will be 1.1 meters. Okay, that's what it is. Okay, G we have to take as 10. Now you try to understand what is the meaning. Why are they giving this height 1.1? Because this object is not taken as a point object, but the center of mass means that point, the center of gravity, where the gravity is acting, that point you have to treat as a that object you have to treat as a point. So actually, if this car is going in a circle, that point is actually going in a circle. The entire car will be represented by that point. Okay, so the radius of this circle, you need to take the distance of this point from the center. Now how much radius will be, because this is already 8.9 and this is 1.1, right? So what will be radius? Yes, this is 1.1. We have to add. So radius, let us use radius as this is, let's just write this as r dash. So actual radius of this circle of this body, that will be 8.9 plus 1.1, that will be 10. Okay, meters. Okay, now the question is what should be maximum speed? That's the question. So see here, mass they have given or not given? Uh, Mass is not given, not given. Okay, not given. So at this point, suppose you draw free body diagram. So mg will be coming like this and normal will be coming like this. Two things will come like this, right? And this this is the speed with which it is going. This is the speed with which it is going, maximum speed. This maximum speed we need to calculate. Now see, there is a very important uh, trick we can think about this. Suppose it is going with a speed. Now it should be safe. It should not lose the contact with the ground. That is the main idea, right? Maximum speed means it is going with a speed, but it should not lose the contact with the road. If lose contact means then it is gone, right? Accident will happen. So maximum speed is that only where it should not lose contact, means you can assume maximum speed is normal almost becomes zero, you can assume that. Okay, normal almost becomes zero. So if normal becomes zero, then only force acting on this body is mg, right? Only force is mg, and that force is acting toward the center. So mg is only the centripetal force. Are you getting this? No, no, no. You are saying the road. Suppose you are talking now, you are not talking of body now. You are talking of road. You are worried of road. What will happen to road, right? Correct? Now you draw free body diagram of road. So on the road, what forces will act? On the road, forces will act normal n. Ah, when normal is zero, what will happen to the road? Why are you worried about that? No, 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 no. You are telling road will no, no. You are thinking of road na. Road normal is always acting. But if you say normally zero means contact itself is not there na. Contact is not there. You understand? See, even if you now I will derive it like this. Let us say some normal is there. Let us say normal is there. Now tell me what is the total force toward the center? Tell me total force toward center. Mg minus mg, and this is the net force towards center, which is the centripetal force. So this will be mv square by radius, correct? Right. Now can you calculate normal from here? What will be normal? Normal will be mg minus mv square by r. Now we should have the condition that this car has to remain in contact with that, right? So that means normal cannot be 0, or you can say normal is greater than equal to 0. Equal to means it is almost going to leave the contact. Okay, this condition we can apply. So if you apply this condition, then you will get now mg minus mv square by r is greater than equal to 0, means mg must be greater than equal to mv square by r. Mass will get cancelled. Gr will be greater than equal to v square. V must be less than equal to root under Gr. So root under Gr should be like the maximum speed with which he has to drive the car. Root Gr is like the maximum speed. Any doubt in this? That's all. That's all. Radius we have given 10, and G is also 10. So 10, 10, 100, 100, right? 10 into 10 under root, that will be 10 only, 10 meter per second. That's the answer. Okay. Actually, for because they are asking maximum now. Maximum means greater than equal to condition you have to take. Equality means almost dangerous position you can see, and equal to 0 means almost like a say dangerous position. So maximum you can become that dangerous position, not more than that. Okay. Okay. Then any other doubts? Any conceptual doubts? Yeah. Which question? One can check. Which question it is? Okay, this one. They have sent this question, right? A car is moving with a speed of this, takes a turn of radius. So a car is going to take a turn like this. A simple pendulum is suspended from the ceiling of the car. Determine the angle made by the string of the pendulum, the vertical during the turning. Okay, so suppose you are driving and you are taking a turn. So this is the car. This is how the car is going. This is like the like this way, right? Wheels. Now you are seeing it like this, but note that car is now taking a turn, means inside, suppose you are sitting inside the car and there is a pendulum which is suspended here from the car. So right now car is taking a turn, means it is having, acceleration toward the center. So this car is having a centripetal acceleration definitely. Okay, is the car also changing the speed? Did they give? Are they changing the speed or not changing the speed? They have not told. They are just saying it is going with its speed, right? It is going in a circle. Simple pendulum. That's all. So that means you consider the only acceleration of the car is toward the center, that is centripetal. Now you want to study this object. So you need to give a opposite acceleration because observer has acceleration this side, correct? So you have to give this acceleration of the observer which is same as centripetal, and gravity is also acting G. So this definitely will not remain in this position, it will go in some other position, right? So that means if you draw the diagram properly, uh, from this position it will go like this, and then it will become G in this way, centripetal acceleration this way, and yeah, this is acceleration. If you want to show forces, you multiply with mass, that is called pseudo force, mg into ma, and this is tension. So these are the three forces will act: tension, mg, and this is called pseudo force. Yes, are you clear about this? So pseudo force is the force due to the observer. Observer is imagining that there will be force acting on this body. That is same as relative acceleration, because if observer has this acceleration, so he will apply. Now see this, he is going to see that address, so they are asking this angle, I think, in the question with the vertical, right? So this you can calculate, because here the sum of this m into centripetal force and this m into g, sum of this has to balance tension, because tension is acting this way and it is in equilibrium. So you need to take the sum of these two, and sum of these two must come along the diagonal, and this diagonal must be exactly in the same line of tension, correct? This line must be same. That means if this line is making theta here, the same line will make theta here, because mg is vertical. So in this triangle you can calculate, because this is MAC and this is MG. So tan theta you can easily calculate from here, MAC by MG. Get cancelled, AC by AG, that you calculate. They have given a centripetal speed they have given. So this is V square by R, V square by RG. This you calculate. Okay. I think they have this speed and other things given, right? What is the speed they have given? 54. 54 kilometer per hour. So convert into meter per second. 5 by 18. 18 into how much? 3, right? So 5 into 3, 15 meters per second. Radius they have given us 20. And G also you take 10. So calculate 10 theta. So 15 square by 20 into 10. That is 225 by 200. This you calculate. Okay. How much will be? 1.15. How much it is? So first to divide this, so 2.5 divided by 100 means 1.125, right? 1.125, and so theta will be tan inverse of 1.125. That's the answer. Okay, right. Yeah, previous questions are coming on this topic, right? Then any other doubts, questions? Ask. Yes, Tama. Worksheet question, huh? Um, Today it is given from this book, but let me check whether I have Raghu. I just sent in the group. Question number 13. Okay, yeah, question number 13 is there. Let us check that. A particle is moving in circular path with velocity varying with velocity changing like this 1.5. Velocity means speed basically here, speed only. The speed equation they have v1 plus 2t. Okay, right. If the radius of circular path, this radius is given as 2 centimeters, then angular acceleration we need to calculate alpha when time is equal to 2 seconds. Okay. So let us try to calculate this. So speed is equal to this. So we can calculate tangential acceleration, which is dv by dt, right? So differentiate 1.5 comes out t square differentiation 2t, 2 comes out t differentiation 1. So 3t plus 2. So we calculate tangential at 2 seconds. You calculate what it is. So 3 into 2 plus 2. So 6 plus 2, 8. Tangential acceleration you got, and tangential acceleration is equal to r alpha, that you know. At 2 seconds you calculate radius, they have given 2 centimeters. So radius you have to keep in meter, 2 by 100 alpha. So alpha will become 800 by 2, that means 400 radian per second square. Check that. Yeah, that only will come now. Yes, come on. Hmm. No, no, if you keep in centimeter, if you keep here in centimeter, but before that note what are you doing here? What is this 8? This 8 what you have calculated, this 8 is meter per second square. Okay, this 8 is meter per second square. Okay, because it is tangential acceleration, other things here is everything in SI unit. Then when you equate with R alpha, you have to make sure this R should be in meters, so that meter will cancels. Okay, meter cancel. If you keep in centimeter and that meter, but meter centimeter you need to cancel out now. That is what it is. The otherwise this meter you convert into centimeter. Suppose if I convert this meter into centimeter, so I will get here 100. Okay, and this I will keep in centimeter. That is how much it is? 2 centimeter. 2 I will keep here, right? Then alpha. So from here also if you calculate alpha, 2 will come and it will come same 4 per second square. But then you will ask, where is radian? Radian is not visible. Radian they will not show visibility. Radian is there because radian actually dimensional wise radian doesn't have dimensions, so it will not come. Okay, radian it is there. Just like for example, see omega. Omega values radian per second, right? But when you write omega in terms of frequency, 2 pi into frequency, frequency is like 1 by second. So it will come per second. Per second it comes now, right? Where is radian? Radian is there hidden. You cannot see that. Radian is there. Okay, understood that? I think my this is not working. 1 minute. My this headset power is gone. 1 minute. Yes, tell me question because my this headset power is not there. 14th question. Let me check that. A grindstone starts from rest. That means initial angular velocity is 0, omega 1, and has a constant alpha. So alpha is given as 4 radian per second square. the angular displacement and angular velocity after 4 seconds. After 4 seconds means when time is interval is 4 seconds. Then they are asking what is the angular velocity, that is omega 2, and they are asking angular displacement. That means they are also asking what is the theta. Okay, that's question. Then you can use, yes, omega 2 is equal to omega 1 plus alpha into t. Directly you will get it now. 4 into 4, so that becomes 16 radian per second, and you have to calculate theta is equal to omega 1 t plus half alpha t square. So this is 0, half alpha 4 into 4 square, so that comes cancelled to 16 into to 32 radian, right? Then any other? Yes, 1 material voice is not visible. I'll try once putting this. Yes, tell me what you're saying. What you're saying? Do it now. Do it. Do it. Do it. Do it. But why do you want to do? Because this derivation of these equations are based on this only. Okay, it is based on this. You do it. Alpha is constant, so alpha comes out. Integration of dt, omega delta, integration of d omega means delta omega it is. Okay, so and this is like delta t time interval. So delta omega, that is what it is. So delta omega means omega 2 minus omega 1. Alpha delta t means time interval, which is t here. That's what you get. All these derivations are based on this only. These formulas, v equal to u plus ats is ut plus half it, all this comes from the integration on this, right? Just like you can also get by graph. You remember graphical way is also there to derive it, and calculus way is also there to derive it. Right. Then any other doubts? See, in uniform circular motion, first of all, you understand in a uniform circular motion, speed is constant. Remember, v is speed here. Speed is constant. Speed is constant. But see the direction. Direction means the velocity is not same now because its direction is continuously changing. Right, velocity is not same because direction is changing. So there is a centripetal acceleration only, but centripetal acceleration at this point it will be this direction. When it is here, then acceleration will be in this direction. When it is here, then acceleration is this direction. Centripetal acceleration magnitude is v square by r or omega square by r. This magnitude is constant. This is magnitude, but you can see the diagram directions are changing. So vector is not constant because acceleration is a factor. So that vector acceleration is not constant. Okay. But if they ask magnitude, magnitude is constant. Right. Then that's all. Anything else? Ask question. Come on. Open anything? Any question? Doubts? Centripetal force. Now you tell me. Yeah, your question is good. Suppose if a body is going in a circle. hmm, like this, okay, so here force is acting, centripetal force is acting like this way, and body is moving this way. Let us consider displacement like this. So displacement will be happening small, 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 small. First of all, we have not discussed about variable force. You remember, we have discussed only about work done due to constant force. You remember that? Remember that? Work done by constant force only we have discussed. That is the syllabus for this. I have reduced the syllabus because in other NEET section they have kept whole up to conservation of energy. But you know, then J we have to reduce syllabus because we are going very slowly, step by step. So variable force we have not taken. Note that here force is variable. Just now we have seen because direction of force is changing. So this is an example of variable force, right? Which is not there next week. Means it will be after next week. Okay, that will be afterwards. But by your question is saying whether it is zero. Yes, it is zero because in case where force is variable, you have to calculate work done as force dot displacement dr. And when you do this calculation, this centripetal force and this small displacement dr is anyway perpendicular 90 degree. That's why it comes zero. Okay. Then done. Any other? What? The resultant is actually my laptop is also making sound, so I'm not able to hear you. Can you be little loud? It's not audible. 1 minute. Yes, tell me. I, two forces? No. What are you talking about? You are talking about dot product now. You are calculating dot product of this, right? Integration comes afterwards. Integration means you are adding sum. So you are doing f dot dr here, this f dot dr here, then f dot dr here, then f, it is summation means it is integration means summation it is, right? So first you are doing this dot product and then you are adding all that small. Actually it is a small work. Okay, it is a small work which is f dot dr. And then you integrate means you want to calculate sum of all this, but all these dot product are 0 0 0 0 0 0 0. So sum of 0 plus 0 plus 0 plus 0 is always 0, right? That's what it is. Okay. Then any question? Yes. Gravity, Earth, yeah, of course, because gravitational force is equal to mg. Gravitational force is mg. So gravitational force depends, but if they ask acceleration due to gravity, no. Acceleration due to gravity is depend on Earth mass only, which you remember g capital M by r square. This we have already seen previously. G is gravitation constant, m is Earth mass, r is radius of Earth. Hmm. Resolution you already know na. Which direction we resolve that also you know na. That means we should know already that which in the direction of acceleration or in the direction of resultant force. We already know the direction of acceleration, so we try to resolve in that direction. Other direction forces will be balanced, right? That is what it is. Yeah, why not? Why not? Why not? Because see the gravity. When you see the projectile motion, you are throwing this way and acceleration is this way. You have seen that now. Huh? So always velocity is changing. and velocity direction and this g are not the same direction. Okay, constant speed like uniform circular motion. Let's take uniform circular motion. Body is going with constant speed. Speed is constant, but direction is changing. Na, direction is changing. So there is a force. So when force is always perpendicular to velocity, this you can say. When force vector and velocity vector are always perpendicular, then it will be a uniform circular motion. Always velocity and force are perpendicular. So in that case, force will not change the magnitude of velocity, but it will change the direction of that, right? But in other case, if force is making some angle with velocity, then force will change both the thing, direction as well as velocity. Take the example of non-uniform circular motion. In non-uniform circular motion, force may be in some different direction, right? Force may be in some different direction. It has two component, centripetal and tangential. So tangential component changes speed, centripetal component changes direction, right? Done. Anything else? Okay. Yes, Taman, tell me. 1 minute, 1 minute. Question number 18. Okay, 1 minute. Today's worksheet only, right? Yesterday's worksheet. Means same, na? The maximum speed at which a car. That question? Oh, the previous worksheet which I have given, na? Okay, okay, 1 minute, 1 minute. This question. Yes. A person is sitting in a car at acceleration. So suppose there is a person who is here in a car, and this car is going with an acceleration. Acceleration of the car is there, and he is throwing a ball. So when he is throwing a ball, this is the velocity of the ball with respect to the car. Okay, he is throwing up. Now he will see, he is the observer who is going to see that. What he is seeing? He will see a gravity acceleration g and an acceleration which is in this direction, because observer is under acceleration, so observer has to give a opposite that, right? I think this question also we discussed in the class. Very important question it is. Conceptually also very important questions, right? So first of all, we need to know that this acceleration A and G2 accelerations will be acting according to this observer. Okay. So now what will be the resultant of these two accelerations? There will be some, because they have given this value g is equal to 10, and they have also given this acceleration A, which is 10 root 3. Okay, so if you make a parallelogram, this will be the resultant acceleration, net acceleration. Okay, so this is 10 root 3 and this is 10. So this angle theta, this will be this divided by this tan theta, so this will be 60 degree. First you should know that. Clear? Right? That angle is 60 degree first. Okay. Then another thing is that you have given a velocity like this. You have given a velocity like this. This velocity is, I think, 20 root 3. Okay. This is velocity. So first you should remember minimum radius of curvature means what? What is minimum radius of curvature? For this you need to look at the projectile motion, because that is the classical example. Projectile motion, you are throwing with you body is going in this way, right? Body is going a projectile motion. Minimum radius, you remember, minimum radius happens at this point. Remember, minimum radius happens at this point where acceleration and this velocity is this only v, this is the only velocity, so velocity become perpendicular to acceleration. There the radius is the minimum radius. First you should know that. Okay, the minimum radius happens where? At this point, at this top point. Radius of curvature is minimum. Radius means here you have to draw a circle, and this radius of this circle is minimum. Radius is minimum. So you how to calculate this radius? Remember this acceleration, whichever is perpendicular to velocity, that acceleration is written as centripetal acceleration, that is v square by radius. Okay, and now here this velocity is ux because that is the velocity, and this acceleration is g. So g is equal to ux square by r. So that's the minimum radius we calculate here. Minimum radius is ux square by g. Okay, so minimum radius is calculated as velocity is which velocity which is perpendicular to acceleration. Okay, the velocity which is perpendicular to acceleration. Anywhere this velocity is anyway remains constant. No, ux always remains constant. Ux always remains constant. So you need to understand the minimum radius is ux square by g. What is ux? Ux is velocity which is perpendicular to acceleration. Okay, so here you have to calculate velocity which is perpendicular to acceleration. So acceleration is which direction? Acceleration means net acceleration. Net acceleration is acting in this way. This is the direction of net acceleration. Okay, this is the direction of net acceleration, and velocity right now in this direction velocity is there. So you need to resolve this velocity in the component perpendicular. How will you resolve perpendicular? You will resolve this component and you will resolve this component is along the acceleration. That is we are not bothering about. We want this component of velocity. So how to calculate that component of velocity? Because this is 20 root 3 and see this is 60 degrees. So this is also 60 degree, right? This is 60 degrees. So this component will be cos and this component will be sine. So this is the component of velocity which is perpendicular. So velocity component perpendicular will be 20 root 3 cos 6 sine 60 degree, sine 60 degree. So how much it will be? 20 root 3 into root 3 by 2. So that will come as 30. This is the v perpendicular. Okay, remember this ux means it is v perpendicular. V perpendicular means velocity which is perpendicular to acceleration. So we got this, then use that formula. Minimum radius is v perpendicular square by acceleration means net acceleration. V perpendicular is 30 square and net acceleration you have to calculate from here because this is 10 and this is 10 root 3. So root under 10 square plus 10 root 3 whole square. So that becomes 20, right? So that becomes 20. So from here 900 by 20, 45 comes. That is the answer. Clear? Done. Okay. So then you work out question. Any doubt is there? You can WhatsApp me. I will be traveling, but I will try to respond. Okay. Any doubts will be there. I will send you the solutions. Okay. Fine. Right. So prepare well for your exam. Any doubt is there? You tell me. Okay. Then we will see. Fine. Okay, or any see to by means tomorrow maximum to maximum you can send doubt means I am here available till morning. So if any problems are there morning also I can conduct class. You let me know. By morning means around 8:30 or 9 maximum. Okay, I will be available. After that I will be traveling. So before that if you want any class or doubt session you tell me. Before that morning also I can take. Okay, fine. Okay. Then good night. Bye bye all. Yes.